Hello everyone, my name is Anthony, and in today's video I'm going to talk about how to make your own development board, which is part 2 of the series from how to make your own microcontroller breakout board using the LPC1769. Now you could replace this with your own microcontroller, but in this particular example I am talking about the LPC1769. In the first part, I basically spoke about how to design the schematic and create your own breakout board. In part 2, I'm going to show you it's already fabricated and I've already installed all the components, and now let's test it out. So what I have over here is the breakout board that I've developed. And based on the schematic that we have over here, let me just pull it out. I spoke about how you can make all these connections. And here we have the 3D version of it. And here I basically designed and developed the actual board over here. So let's go and test it out. So what I'm going to do is I'm going to connect the programmer to the board. I already have a code running. Here we go. So there's an LED mounted so that we can test some pins, and having an LED helps us know whether the code is running or not. So I'm going to open MCU Espresso, which is the development environment that NXP generally recommends. And there are 3 pins connected to the LED. Unfortunately, one of the pins, the red pin, is not functioning properly. I believe there's either a soldering issue or connection issue because it seems to be shorted, and I need to debug it. But for now, I just want to get some things running, and let's see how it works. So right now the green LED is flashing. So let's try to make the blue LED, or make 2 LEDs run. So if I put it at logic level 0, that basically allows the code to turn. That enables the LED. So let me explain a little bit about the code. I'm using the peripheral Blinky example. Now you can download all these examples from the NXP website itself. Now, depending on the development board you're creating, you can go to the manufacturer and download the device drivers and development code so that you can get started quickly. And the code is pretty straightforward. What we do is we initialize the pins to be a general purpose input-output. We set the directions to be output. And then you'll be setting it to be whether you want it to be a high or a low. And you'll be setting it to be all low. All right, so I'm going to save this. I'm going to build it. And now I'm going to download it. So now you will shortly see this going to be programmed. It's flashing. Now you have a greenish, bluish LED running. Now mind you, over here we also have pin number 22, which is supposed to be red, and it's not working. So what I've done, at least the LED is not working, but the pin works. So what I'm going to show you is through the logic analyzer. I'm going to create a new session, and I've already connected my logic analyzer. I'm going to put this orange pin from the logic analyzer right into the pin where pin 22 is connected. And let's see whether it's going to be logic level 0. And as you can see, logic level, the MISO, which is just a label, which is the orange, it's low. And when I remove it, it's going to be high. And then again, when I put it back in, it's going to be low. So that basically shows that the logic is working, the code is working, and everything, at least from the pin, from the microcontroller perspective, everything is working. Though there might be some connection issues with the LED. But nevertheless, at least I can debug and test it. And that's all there is to this video. If you like videos like this, do subscribe so that you'll be notified, and also do like the video below. It can help my channel a lot. Thank you so much.